One of the concepts that every beginner in any programming language must master is the concept of variables. A variable is essentially a place to store information in the computer's memory. Just like we have a memory that allows us to save certain information, the computer also has a memory in which it can store different information you assign to it. In our case as humans, for example, if I told you that my dog's birthday is on February 5th and immediately asked you when my dog's birthday is, you would surely answer that it's on February 5th. What your brain has done is stored that information somewhere so that you can access it immediately. Another example is if I indicate that there is a 5 peso coin on my desk and ask you how much the value of that coin is, you would surely answer that it's 5 pesos. Or finally, if I told you that a cajeta candy costs 10 pesos and asked you how much the cajeta candy is, you would say it's 10 pesos. This is because your brain has stored this information in a space of your memory. The same happens with computers. Looking at a more practical case, here we have an image from a video game and you can see that we have information in different parts. For example, here we have progress of 10%. This 10 is representation of data through a variable. That is, somewhere in the memory of this device, this data is being stored and is being displayed in this way. Similarly, we see that we have here the time left for us to complete this race, and we have a different format than this 10%. Lastly, we have a speed indicator at the bottom which shows 171. These 3 data points are 3 different variables that this application is using in this case. Another example is the case of Microsoft Word. When you are editing a text, you assign a font size. That font size will indicate how big or small the size of your letters is, and that is also represented with a variable that you can change as you use it. We also have here a type of font. In this case, the selected font is Calibri, but you can change it at any time. These are also representations through variables. Finally, we have here the case of a mobile application, and we see that we are also flooded with information that is represented through variables. We see that we have here one piece of data, here another piece of data, here another piece of data, and here another piece of data, apart from the data in the graph and from these 2 graphs below. Therefore, we can find the use of variables in all applications. And remember, a variable is a place to store information in the computer's memory. Now, how can we declare the different variables in a C# application? First, there is one thing to keep in mind. There are many types of data in C# such as integer data types, floating point number data types related to text strings, etc. To clarify the concept of a data type, in the case of C#, let's draw an analogy with the different types of screwdrivers and the various screws on the market. Looking at these images, we can notice that if we have a screw of the type shown here, we would need a screwdriver with the type of tip we have here. This one labeled as slotted implies that if you try to insert this screwdriver into this type of head, you simply wouldn't be able to, or it wouldn't work, because the head doesn't match the type of screwdriver we need to remove this screw. The same goes for the other screws. If you notice, we have a screwdriver for each type of screw. Here we have different forms. In the world of C#, consider each screw representing a data type, and the screwdriver represents a data type. This means that, for example, if we had a data type that was an integer, we should use a data type integer. If we had a data type here that was a string, we should use a screwdriver or a data type string. We wouldn't be able to put an integer data type in a data type that was a string. I hope this analogy clarifies the concept of data types a little more. So, now that we understand data types, I'm going to leave in the annex section this link to my personal blog, where I've made a chart representing the different primitive data types most commonly used in C#. This primitive data type refers to the simplest data types, so to speak, in C#. So, we have here the data types int, long, float, double, decimal, string, char, and bool. Those are the most common data types in C#. Looking at the chart, we have a description. For instance, the data type int indicates that we can only use whole numbers. Here we have the size and the range. This representation of range is just so you know from which number to which number you can use a variable of this data type. For example, I've made the conversion of this -2 to the 31 and we see it gives us this result. This implies that this is the minimum number you could use for assigning a int type data. And similarly, if you notice, this is a negative number. But we also have a positive number here, which is more or less the same amount, but positive. We have here an example of use. If we wanted to use this in code, we could do it this way. We can see that if we wanted a larger number than the one we have converted here, we would have to use a long data type. For instance, you will notice the size is twice the size of an integer data type. So, if at any point you need a bigger or smaller number than the one we have here, you could use a long data type. We have here how it is used. If you notice here, we have to enter an uppercase L to be able to use the long data type. Further down, we have floating point numbers, which are numbers that contain a decimal point. We see that we have the float data type, which has a size of 32, and you'll notice this range already contains a decimal point. In this case, minus 3.4 by 10 to the negative 38 power, and we can see that the use example is this one we have here. We notice we use an uppercase F letter if we want to use it in code. Right now, we are going to see how to use it in C#. We also have a double data type that has even higher precision than a floating point data type. Lastly, we have a decimal data type, which is even more precise than the previous data types. This means you should use this decimal data type in case you want to handle monetary values or a very exact data type. We realize the size is 128, meaning a much larger range than the previous data types. So, it's ideal to use this type if you require highly precise operations. Use this double data type for less precise operations and this float data type for even less precise operations. We also note that we have string or sequence data types, which is a sequence of characters. Here's an example where we have a string within single quotes, as we observed in a previous example. We also have a char data type that stores only one character. Here we assign a letter X. We can't allocate more letters as in the case of a string, so we will assign only one letter when it's this char data type. Lastly, we have a bool data type that basically allows us to know whether a value is true or false, more precisely, whether its value is true or false. We see that the initial assignment equals false. Before we continue creating programs, we need to learn about three very significant concepts in Visual C#. First, we have the concept of a statement. A statement is a command that performs an operation, such as calculating the result of an addition, or as we have done previously, printing on the screen or in the console a text, like this hello world we have here. So, this is a statement, and we will be using different statements throughout the course. If we want to recognize a statement, it's enough that we see it ends with a semicolon, for instance, like this console.writeLine we have here. The second concept we need to learn about is identifiers. An identifier is the name used to name an element in your program. For example, a namespace, a class, a method, variables, etc. Even though we haven't seen many of these concepts, they all follow the same nomenclature to identify them. There are some rules for naming these identifiers, like you can only use letters, digits, and underscores. Let's practically see this by renaming this class, which, if you remember, we previously named program. So we mentioned that we can use letters, whether uppercase or lowercase. For example, result would be a completely valid identifier name. We can also use an underscore, either at the beginning of the identifier, as you can see here there is no problem, or at the end or in the middle of the identifier. As you can see, there are no issues with underscores. We can also use digits as long as the identifier does not start with the digit. So, for instance, we could rename this variable as nav1 and we see that there is no problem. However, if we try adding a buratiyad pro adidayad I wandawiyao kyo ipe ari even errors before ipuari, ari titadin, ari te, nave1e, iy, we immediately see Visual Studio notifying us about an issue, even though the message displayed is completely different from the cause of the error, which is mainly that we have a digit starting an identifier. This rule should be remembered to avoid this error. Hence, we remove the 1, is, otis, is. Whatever digit that is not a normal digit, a letter or an underscore is utterly invalid. For example, if we try to use a $sign after nav1, BST, we see an error. Or if we try using any other symbol, we see it marked as an error. An essential point to remember, which we had mentioned before, is that C# is case sensitive. Therefore, exactly how you write it, you have to use it afterwards. The last important point is that there is something called keywords in C#. What do we mean by keywords? Certain words are restricted for use in an application. This is because the compiler or Visual Studio identifies those words for a specific purpose. Therefore, we cannot use them as part of our programs. If we go to the official C# documentation, we will find an article called C# Keywords. Here, we essentially have a table with all those words that are reserved for the exclusive use by Visual Studio or C#. So, for example, if we try to use any of these words as part of our application, for example, this abstract or break, we'll see what happens in our application. Okay, we type abstract, and we see that we have an error here. This is because C# or Visual Studio knows that this syntax is incorrect or this word should not be used. Let's try using another restricted word, for instance, break. Okay, we see that we also have a problem. So, the use of any of these keywords in your application will basically show you an error, so you'll need to avoid them. I am going to leave this link as part of the annexes to this lesson. So, having seen an overview of data types, let's go back to Visual Studio and learn how to declare a variable. How do you declare a variable? There is a simple formula. It is the data type plus the name of the variable plus a semicolon. What I just did is called a comment. We'll see exactly what that is later. For now, simply learn this rule, and I suggest you practice as I write. So, we said this is the formula. Firstly, we need the data type. We obtain the data type from the left side of the table and see it says primitive data type. Let's assume we want to store an integer. Therefore, we'll use the data type int. So we will write int. Notice how it recognizes it as a valid keyword. Here it even indicates that it is a keyword called int. I leave a space and then the name of the variable, which has to follow the rules I mentioned before regarding identifiers. So let's name the variable and finally indicate that we need a semicolon. So we write a semicolon. See, now we have a completely valid program. If we compile this program, we see that we have a successful compilation. Okay, so this is the formula that you have to learn to create a variable. From this point on, we can use this variable with this name or identifier that we just declared in our program, which will contain only an integer data type. You might ask, what's the use of what I just did? Or how can I store a value as part of this variable? Well, the answer is that once you declare this variable, you can use it in the following way. If you notice, the IntelliSense in Visual Studio detects that we already have a variable called variable. So we are going to select it and we are going to indicate that the value of this variable is, for example, 3. As this is an announcement, we must delineate with a semicolon. So basically here we are in 2 steps, declaring a variable and subsequently assigning a value to that variable. Therefore, from this moment on, this variable named variable is going to have a value of 3. How can we verify this? Very simple, we are going to write the name of this variable inside console.writeLine. I am going to remove this string of hello world and we are going to write variable inside it. We will proceed to run the application and we see how the number 3 appears here. The value of this variable can change as we execute the application. For example, after this console.writeLine, we could indicate variable is equal to 5 semicolon. Then we copy this console.writeLine and we paste it immediately after the assignment. The idea of this is to first display the value that the variable contains in this first console.writeLine, and later, after it has changed in value, we are going to see what value it has here. We are going to again run the application. And we see that in this instance, it effectively prints first the number 3 and then the number 5. This means that when you proceed with a writing assignment in this form, or an assignment with the equal sign, the value that the variable previously held completely disappears. So, you must be careful with any assignments that you make in your variables. An important point is that whenever you want to use a variable, you must declare it in this way, that is, following the formula we have here. Although we also have another formula which is very similar, but it saves us a line of code. This is the formula: data type plus variable name plus equals sign plus value and finally a semicolon. So to follow this formula, I'm going to declare another variable. Thus, I define the data type as int, for example. The variable name will be equal to variable2 followed by an equals sign and a value, in this case, for example, 10. Remember to place the semicolon, which is mandatory. Then I will copy the value of variable2 and paste it in this second console. WriteLine to see what it displays. Let's run the application. We can see that we indeed have the printout of the number 3, which is the value of the variable before this console.writeLine, and then we have the printout of the number 10, which corresponds to this console.writeLine of variable 2. Since variable 2 was assigned the number 10 and it hasn't changed since its creation, that's why we have this value 10 available here. If I were to run the application, what would happen if I wanted to use variable 3? It's a variable that does not exist. We can immediately see that Visual Studio detects there is a problem and indicates that the variable 3 does not exist in the current context. Or in other words, I haven't created it yet. If I wanted to create it, I would have to do it as we have done previously. In this case, I am going to declare int variable 3 equals to 50, for example, and we can see how the error disappears. Finally, you can declare different variables of the same data type in one line. For example, if we wanted to declare these two variables on the same line, we could specify int variable 2 equals to 10, variable 3 equals to 50, and remove this line that makes the declaration below. If you notice, it doesn't mark any issues in red, which means this is completely valid. If you want to do this, you need to make sure to separate the declarations of the variables with a semicolon, and only define the different names of the variables, with or without a value. As part of the recommendations for naming variables, here are some. First of all, I do not recommend starting the declaration of a variable with an underscore. Even though this is completely valid, it can limit the interoperability with other .NET related languages. Therefore, I don't highly recommend this. Secondly, I do not recommend having variables that only change in one letter. For instance, suppose you have a variable declaration and then you have another variable declaration. You can see that neither the compiler nor Visual Studio marks any problems. The issue with this is that these two variables are very similar, and if you wanted to assign a value to one variable, you could mistakenly assign it to the wrong variable, which in this case is the first one. So I do not recommend having variables that differ only by a letter. Another common declaration in C# is naming variables in lowercase. So if you've noticed, I've declared variables in lowercase up to this point. This is a recommended practice because it adheres to the way variables are named in C#. You might wonder, what if I have a variable with two words? Well, in this case, I recommend keeping the first word entirely in lowercase and capitalizing the first letter of the second word. If you see ME is in lowercase and the first letter of variable is in uppercase. What I'm doing here is annotation, specifically called camel case annotation. If you notice, we have a form here that simulates a camel's hump in the V, while the M simulates the head. So this way of naming the first word in lowercase and the first letter of the second word in uppercase is called camel case. The last point is that I do not recommend using Hungarian notation. Hungarian notation refers to having the first letter of the data type before the variable declaration. For example, int variable equals 10. In this case, the initial letter of the data type is always placed before the variable name. Other examples would be, for example, bool b response equals false. If you see here, we are indicating that the b corresponds to the Boolean data type, followed by the variable name. This can add a bit of complexity to your applications, so I recommend always keeping the variable declaration simple using the above recommendations. To conclude, you might have asked yourself, what happens with variables that have not been assigned but you want to use, for instance, in a console write line? Let's do a demonstration. We will create a variable named unassigned variable with a semicolon. Up to this point, everything is valid. If we wanted to use this variable in a console write line, we will see an error pops up indicating that we want to use a variable to which we have not assigned a value. This is an area where Visual Studio greatly helps us. We might forget to assign a value to a variable, and although in other programming languages this approach could be used, it would cause an error here. For instance, we would be printing a random value without any sense. So it's an area where Visual Studio supports us to avoid making these types of mistakes. Now that we know how to declare a variable, it's important to know how to use the different data types at our disposal in Chash. Let's modify this file we have been working on. We'll remove almost all lines except for this last one indicating console.readline so that the application halts when we click on Start. Returning to my blog page, if you remember, we have here the different primitive data types available in Chash, the most important ones. We will start to analyze them one by one, starting with those that are not related to numbers, that is this Boolean data type. As you can see, it is declared this way and the assignment is like this. So I'll write before this console.readline, but after the main brace, a declaration as we saw on the page example, that is bool with double O. As you can see, Visual Studio recognizes it immediately. And let's name the variable as, for example, isClient. This data type can contain two values, true or false. So let's suppose that we want to indicate that a person is indeed a client, then we insert the value true. This variable will only store the value true or false. This data type can only contain true or false, which are equivalent to the real terms true or false. Then let's write a console.writeLine, and within the parentheses is client. Remember to put the semicolon to avoid any issues. Let's proceed to execute the application to see what is displayed. We see that it is displaying the true value, which is the same value we specified here. That is a true value. Let's stop the application and change this value to false and run the application again to see what is displayed. And we see that on this occasion it is displaying a false value, which is the value we assigned to the client variable. If we try to place a number here, for example, Visual Studio detects that there is an error and indicates that a conversion from an integer type to a Boolean type cannot be done. So remember, a Boolean value can only contain two values, true and false. Let's leave the true value and proceed with the next data type. The next data type we will see is called char. So let's declare another variable indicating that we want the char data type. Let's name it character. And to declare a char type data, we have to specify it within single quotes. Visual Studio automatically completes the closing quote and a semicolon for you. Within these single quotes, we are going to place the character with which we want to work. For example, the character A. I'm going to proceed to do another console.writeLine, and we're going to pass the character as a parameter. Remember to place the semicolon and parentheses, and let's see what is displayed. we see that it displays the value a, which is the value of the character that we specified in this assignment. Here we can place any character, for example a number. It is a character after all. We can also place a question mark, a capital letter, or a lowercase letter, as long as what goes here between these single quotes is a character. If we try to add another character to this definition or to this data type char, which is character, we will see what happens. We see how the study did it. It places a red mark and says that we have many characters in the literal character type. That is, we are trying to place more than one character in the data type char in the character variable. Let's then remove this character, which is causing us problems, and move on to see the next data type. The next data type is this string data type, which tells us that it allows us to store a sequence of characters. We have here an example declaration. We then return to Visual Studio, and we are going to make a declaration of a string data type. We are going to name the variable, for example, name. This will be equal to, and to specify the string data type, we will place a pair of quotes. We will place the closing semicolon. If you notice, it's a pair of quotes and not a single quote like we previously did. Within this pair of quotes, we can place more than one character, for example the name Hector. We will place a console.writeLine to display this variable called name. Let's click Start. And as we can see, this time it is displaying a set of characters that makes up the string Hector. Then we see that the difference between the char data type and the string data type is that char only accepts one character and string accepts more than one character. We could, if we wanted to, place a single character. It does not pose a problem, but unlike the char data type, here we can add more characters. Again, these can be numerical characters. They could also be special characters, for example, a pair of parentheses, dollar signs, etc. Here in the example, we see how they are displayed satisfactorily. Now, these data types are primitive data types unrelated to numbers. If you notice, we use characters here and true or false values above. We are going to work or see what happens now with the numerical data types. We return to the web page and start with the data type int or integer, which is one of the most commonly used data types in C# development. Here in the description, we can see that this data type allows us to store integer numbers, and here we have an example of its use. So let's go back to Visual Studio and declare an integer variable. We define the data type int. We will assign this variable, for example, integer equals to 3 with a semicolon. We then write console.writeLine and proceed to display the integer variable. Let's see what the console prints. And we can see how successfully we are printing the number 3. Now, if you recall, we carried out the conversion on the wolframalpha.com page of this minimum value we could store as part of this integer number. And we found out that this is the smallest number we can store in this data type. Let's check if this is true. Let's copy this number. So we write here int integer equals 2. And see how Visual Studio has no problem with this number. We execute the application and this integer number is correctly displayed. However, what I'm going to do next is subtract a number from this number we obtained. Instead of having a number 8, I'm going to enter the number 9. We immediately see how Visual Studio alerts us about an error. The error is that a long data type cannot be converted to an integer. What does this mean? It means that we are trying to assign a larger number to an integer variable. In other words, we are exceeding the amount of memory space that can be stored in an integer data type. The same occurs for the positive number. If we take the positive range is 2 to the 31 minus 1, then I will make the conversion 2 to the 31 minus 1, and this is the maximum positive value that we can assign to an integer data type. We will copy this number and paste it as part of this integer variable. We see that we do not have any problem. However, if we try to assign a larger number, we see Visual Studio detects a problem again. This is how we can know what is the minimum and the maximum value that a data type accepts. In this case, the int data type. What would happen if we wanted to assign a value like this to a variable? We would then need to use another data type. If we go back to the web page, we see that we have a data type that allows us to store double the size, which is the long data type. Let's return then to Visual Studio and let's write the long data type. We are going to set integer 2 equals 2. We are going to assign this problematic number in the int data type, and we will make a console.writeLine of integer 2. Let's subtract 1 from this integer value so we don't have problems, and we see how, unlike the previous time, at this moment this long data type has no problem handling this number. We can even assign a larger number, adding more digits, and see that there's no issue with this data type. When we run the application, we see how it correctly displays both the long data type and the int data type. Now, what would happen if we tried to assign a decimal number to one of these integer data types? Let's see what happens. We will try to put a decimal point to this integer variable 2 and see that an error occurs saying that we can't implicitly convert the double data type to long. This means that integer and long data types do not allow decimal numbers. For this, we have specific data types to handle these situations. In this case, the float, double, and decimal data types. Let's start analyzing the float data type, which handles lower precision than the other three. We will declare a float data type variable. We are going to call it float1 and assign it as equal to 3.1416. Although it seems that everything is fine, Visual Studio is signaling an error. It indicates that we can't implicitly convert a double data type to a float data type. It provides the solution to this problem. It tells us that we have to add an f suffix to the written number, meaning we have to write an f after the number we put in. When you work with floating point data types, add an f at the end of the number assignment to avoid any issues. So we're going to write console.writeLine number float1, run the application, and we see how the decimal number is being printed satisfactorily, which is stored in a variable called number float1, which is a float data type. Let's do another test. We're going to indicate float. Number float2 equals, and we're going to assign it a larger number, for example, 214 point, and some random numbers. As you can see, we have a fairly large number. We don't have any problem with Visual Studio, so we're going to write console.writeLine number float2 semicolon. For the record, I have entered 16 digits after the decimal point in case you want to replicate this example. So we're going to run this application to see what happens. Here we can notice that we have a small problem if you want to see it that way. It's that here the number is not printing all the quantity that we specified as part of the assignment. You can notice that the data is then truncated, meaning a rounding off of 7484 is taking place here. We wrote more decimal numbers. This is what I was mentioning that has to do with the precision of a data type. Let's look at the example with the double data type to better understand this. So I'm going to declare double number double, and it's going to equal 3.1416 semicolon. In the case of the double data type, when assigning you don't have to write anything else. Automatically, Visual Studio infers that this number is a double. Then let's write console.writeLine double number 1. We run the application. And we see that it prints successfully. Let's then write double number 2 is equal to, and we're going to copy the number we have up here, removing this letter F so that it is a double number. Then we write console.writeLine double number 2 and test the application to see what is displayed this time. You can observe something curious here. In the assignment of the float data type, if you remember, the number was truncated to 4 digits after the decimal point. However, with the double data type, we see that we have a larger set of numbers after the decimal point. This means that the double data type allows us to store numbers with greater precision than the float data type. Thus, if you need something with much greater precision than a float type, you have to use the double type. However, there is a more specific data type that allows us even greater precision. This is the decimal data type. As you can see, it has a size of 128, and this type of data is recommended for working with monetary values. Let's proceed to an example. We declare a decimal data type, naming it decimal number 1 equals to 3.1416 semicolon. An error is showing here, and if you remember, this is because if you don't put any letter after the number, Visual Studio infers that this number is a double data type. To fix this, we need to place an M after the number to indicate that it's a decimal data type. Directly writing console.writeLine decimal number 1, and I'm going to declare a second variable decimal number 2 equals. I'm going to copy this big value we have here, paste it, remember to place an M after the number, and then console.writeLine decimal number 2. We'll now run the application. Okay, and this time we see the decimal data type displaying the value 3.1416 successfully, and then showing the whole number we wrote as part of the C# code assignment. That is, after the decimal point, we have all the digits. And this is because this data type is the most precise when required to work with decimals. Hence, it's the data type that you should use if you want to work with money. In this way, we can work with the different primitive data types available in C#. We'll be using these data types quite often moving forward, so I recommend studying this lesson until you fully comprehend it. Now it's time to talk about operators. These operators are the same ones used in mathematical expressions or mathematical problems. I am going to delete all the previous code, leaving only this line of console.readline, and to remind you, the main operators are plus, minus, multiply, and the division sign. You probably know how these operators work, so let's learn how to use them in C#. Let's start by declaring two variables. The first one will be number 1, which will be 3 for example, and we are going to declare a second variable named number 2, which will be 5. If we wanted to get the result of the sum of these two values held by these variables, we could declare a third variable named, for example, result that will be equal to number 1, and here we can apply one of the operators, in this case the addition operator, so we indicate number 1 plus number 2. The result of this operation will be assigned to the variable named result. Let's see if this is true. Let's write console.writeLine and write in brackets result, place the semicolon, and let's see what happens if we run the application. Okay, we see that the result is 8, which is correct since 5 plus 3 equals 8. This is how we can apply operators between two variables or two different numbers. We can also apply these operators directly to the console.writeLine method. For example, we can indicate console.writeLine and in brackets denote that we want number 1 multiplied by number 2. If you notice, we are indicating here that we want to carry out this operation and then print it with WriteLine. Let's see what happens if we run this application. Perfect, we see that we have the number 15, which is the result of multiplying 5 by 3. These are the values stored in number 1 and number 2. Similarly, we could apply this operation directly from console.writeLine. If we didn't want to use variables, we could, for example, multiply 8.5 by 12.2. We can run the application to see what happens once more. We see that the result is 103.7, which is the execution of this operation we have here. At this point, you may be wondering, is it possible to use these operators with other types of data that are non-numerical? If you notice, we have only used variables that contain numbers, but what would happen if I wanted, for instance, to do a console.writeLine with two strings? So we can write hello. Remember that to write a string you have to use double quotes. We can apply the addition operator and we will write into the quotes world. We put the semicolon and you can see that we are using two data, this data of hello and this data of world. and we see that we have here the addition operator. You'll see that Visual Studio isn't marking any errors. This implies that the compilation is successful. Let's see what this code that we have written here outputs. And we see what C# and Visual Studio are doing is concatenating the two strings. The word concatenate refers to joining. We see that we are joining hello and world. So what we have here is equivalent to having everything in a single string in this manner. One important clarification is that with strings, the addition operator is the only one we can use. If we wanted to carry out a subtraction between two strings, we can see this marks an error, and it indicates that the subtraction operator can't be applied to one string and another string. In the same way, we cannot apply the multiplication symbol nor the division symbol. The same applies to booleans, for example, and something different happens with the char data type. Let's attempt to concatenate one letter A with another letter A. Let's run the application. Here, as we can observe, it is not concatenating the two letters A, but instead, it's printing here 194. This is related to something called the ACI code. This is basically the representation of a character in decimal and hexadecimal formats. The value of this character A is the decimal number 97, and here, if the plus operation is truly applied, then the decimal number of this A plus the decimal number of this other A gives us 194, which is 97 times 2. This might seem a bit confusing, but it's really not. If you would like to investigate more about this topic, I have included information about this code in the resources for this lesson. Lastly, you should be careful when you use the concatenation symbol. Remember, concatenation is about strings. So if we have one letter A and another letter A, in this case, it will concatenate these two letters A because the plus operator applies a concatenation of the two A's. And here we have it. We should be careful because if we encapsulate a number 2, for example, between these quotation marks that represent a string and apply the plus operator, you might think the result should be 5. But as this is a string and this is another string, the actual result will be 23, which is the concatenation of number 2 and number 3. So be careful when applying this plus operator, especially when dealing with strings. Another key point, which relates to the area of operators, concerns the result yielded from an operation involving an operator. The result is closely linked to the operands. The operands essentially represent these numbers or data points on which the operation is carried out with the applied operator. What do I mean by this? It means that we could have, for instance, a console.writeLine and could carry out the operation of division by 10 and 3. If we use our calculator and carry out this operation of 10 divided by 3, we will obtain this value. Let's see what happens when we execute the application with this statement. We find that the printed result is 3, which is starkly different from the value we got on the calculator. This happens mainly because we are inputting two types of whole number data. If you notice, this 10 is represented as an integer and this 3 is also represented as an integer. If we wanted to get a double type value, we would need to specify a double type input, in this case 10.0 and also 3.0. Let's proceed to run the application and see what happens. We find that this time we get the value 3 and multiple 3s. This implies that the operation was carried out successfully. But we needed to specify the decimal point to indicate that these values are double values. One might wonder what happens if I do this, that is, input an integer value and apply division on a double value. Let's see what happens with Visual Studio. We can see that the Visual Studio or the compiler automatically makes the necessary conversion to give us a value with decimal points. However, this practice is not highly recommended, as you might input some values without knowing the exact outcome. Therefore, I recommend that whenever you're going to input values for an operation, always input the type of data you want to obtain in the end. In this case, two double values. As part of the operators, we also have a one called the remainder. To jog your memory, here we have 3 operations in division format, and you can see the different parts of a division. we have the dividend, the divisor, the quotient, as well as the remainder, which is the value we have at the bottom. Normally, when we apply the division symbol in an operation, we obtain the top result, which is the quotient. But what if for some reason we wanted to obtain the remainder? That is, how much is left over from the operation. In this third example, we see that we have a remainder of 19. If for some reason we wanted to obtain this remainder, we have a very simple way to do it from C# by applying the remainder operator, which is nothing more than the percentage symbol. Let's do a couple of tests. We are going to indicate console.writeLine and perform this operation, 8764 divided by 4. We carry out the operation 8764 divided by 4 and let's see what gets printed. You should note we are applying the division symbol on this occasion. Here we have the result 2191, which, if you remember from the image, is the result at the top. If we wanted to get the remainder, this 0, we could very well apply the remainder operator. So we change the division symbol for the remainder symbol, then we execute the application. Perfect, here we have the remainder, which in this case is 0. Let's now do this third example, where we get a remainder of 19, so we have to divide 546 by 31. We divide 546 by 31, applying the remainder operator, we run the application, and we successfully obtain the remainder. Now we are going to discuss the topic of infinite numbers, and another type which is nan or not a number. What would happen if at any given moment we wanted to get the result? Let's call this variable infinity, which is equal to 5 divided by 0. We see that Visual Studio immediately warns us that this type of division cannot be done. However, if we change this data type from 5 to 5.0, that is, from an integer to double, and likewise convert the 0 to a double, we see that it no longer gives us an error. Theoretically, what we have here should not return any result. Now let's use a console.writeLine command and print the variable infinity. We run the application. And we see that at the bottom is the result of this division. It looks like an 8, but it's actually not an 8. It's indicating that this is an infinite number. To show you again, let's change this 5.0 to 10.0, and we see that again we get this symbol that represents infinity. This means that we are actually getting the definition of an infinite number here. On the other hand, what would happen if we were to divide 0.0 by 0.0? Let's declare a double variable and call it none. It will be equal to 0.0 divided by 0.0. Let's use a console.writeLine command on none. Remember, none means not a number. Let's run the application. And we see that we get this representation of nan, meaning that this division we're doing here is not a number. Why is this? Because the value of the nan variable must store the value of 0, but at the same time, as we are dividing by 0.0, it must represent an infinite value. Therefore, the representation or the value we get from this division is not a number. So we get this definition of nan is equal to not a number. Another important point you need to keep in mind is something called precedence. To explain it with an example, what would happen if we wanted to perform this operation? 5 plus 10 times 2. Can you tell me what the result is? Here we could get two possible results. If we carry out the addition of 5 plus 10 equals 15 times 2 equals 30. However, if we performed the multiplication operation first, 10 times 2 equals 20 plus 5 equals 25. What would be the correct way to perform this operation? Well, this has to do with the precedence I mentioned. In Microsoft's documentation, we have this page that talks about the operators of C#. Here are listed the different operators and their precedence. This precedence means which operators are going to be applied before others. That is, these primary operators are the operators that if the compiler finds them first, it's going to execute them before any other operator. we see that here we don't have any of those we've seen so far. If we move on to unary operators, we also don't have the multiplication, division symbols, or any of them, but we get to the section of multiplication operators, where we do find multiplication, division, and remainder. Subsequently, at a lower level of precedence, we have additive operators, which are addition and subtraction. This means that multiplication operators, that is, a multiplication, a division, or a remainder, will be executed first, and subsequently an additive operator, an addition, or a subtraction. Therefore, the correct result of this operation would be 10 times 2 plus 5. The result should then be 25. Let's run the application to verify that this is correct. We see that indeed the value 25 is displayed here. Now, what if at any point you wanted to perform the addition first and then the multiplication? There's a handy way to do it. Let's copy this line, paste it, and the trick is that we put parentheses around the operation or operations we want to run first. In this case, we're indicating we want to first execute this addition and then the multiplication. Let's see what happens with this code we just wrote. We see that indeed the value 30 is displayed here. With this, we are then forcing the addition first and the multiplication subsequently. Now, you might be wondering after seeing this, what would happen if I wanted to carry out an operation with operators that have the same precedence. This means that I'm applying the division symbol and possibly the multiplication operator. Both have the same precedence. What would the correct result of this operation be? Well, this has to do with something known as associativity. Here we have a table representing associativity. We see that multiplication and division operators have left-to-right associativity. What this left-to-right topic means is that the operators will execute from left to right. While if we have a right-to-left associativity, the operators that are on the right to the left will be executed first. Meaning in the case of our operation that we have here, this division will be performed first and subsequently the multiplication. Let's see if this is true. We run the application and we see that the result is 1, since we first carried out the division of 5 by 10, which is equal to 0.5 multiplied by 2 is equal to 1. So, these two topics or these two concepts must be very clear to you to know how an operation will be carried out at a certain moment. Let's stop the application, and there are a couple of concepts we need to see as part of the operators. Let's start with an example. Writing a variable called conteo, which will be equal to 0. If we wanted to increase the value of conteo, which is 0, by 1, we would perform a console.writeLine print to show you practically. As we were saying, if we wanted to increment conteo, you might think we could do this by saying conteo is equal to conteo plus 1. What we're doing here is that we're going to add to the value of conteo, which at this moment before this operation is equal to 0 plus 1. This means that after performing this addition operation, we would have a higher value in the conteo variable. Let's run the application to see if this is true. We indeed see the values 0 and 1. This value is the value of conteo and this one value is the value of conteo plus 1. Since this is a very common task developers do in C#, and in fact in several programming languages, there's an operator represented as double plus, that is plus plus. By applying this double plus operator, we are indicating that we want to add the value we have in the same variable plus 1, that is, what we have here is equivalent to having this at the top. Let's see if this is true. Console.writeLine and we'll print again with TO. Okay, you can see that we have the numbers 0, 1, and 2. Later on, we will see how this concept of incrementing plus plus is used more frequently, but for now, hold on to this concept. Similarly, if you wanted to decrement the count variable, you could use minus minus. For example, count minus minus. However, there is another method where you can apply the minus minus before the variable. Let's see what happens if we print the count variable after using minus minus. As you can see, we are successfully initializing the variable and subtracting 1 with this line of code. Then we are incrementing with count plus plus, which is why we have this 0. And finally, we are decrementing with minus minus count. Hence, we have these values of minus 1. You might wonder, what is the difference between this and that? Well, firstly, the difference lies in that this form is called the postfix form. Post as in after, and pre as in this case, or the prefix form, means that the symbol or the operator is before the variable we want to decrement. So remember the postfix form and the prefix form. The main difference lies in how the execution of this addition or subtraction that we have here, which could also be, by the way, a plus plus. So, not to confuse with the variables we have previously, let's declare a new variable called count2 equals to 10. Let's do a console.writeLine and print count2 plus plus. Afterwards, we reinitialize count2 with the value of 10, and then we use a console.writeLine for incrementing count2. If you notice, here we are using the postfix form and here the prefix form. Here we change the name from count to count2, which is the correct variable name. Let's start the application. Let's only consider these last two values. If you see here, we are first printing the value of 10, looking like nothing has been added to the variable count2, but in this form of incrementing count2, we do get the result of 11. You may think this is not working correctly, but what's happening is that console.writeLine first takes into account what it sees first, in this case the variable count2, that's why it prints the value of 10 and then it does the sum to count2. In this second form, the sum operation on variable count2 is first performed, and that's why we're getting the correct value of 11. For it to be clearer, we are going to print count2 after we have added this value. Let's run the application. See how here we are printing the number 10 that has to do with this line here. We print the number 11, which is the assignment of count2 once we have made the addition to variable count2. Then we are printing the sum of count2 plus 1, which in this case is 11. So, this is the main difference between the prefix and postfix forms. The postfix form is more common and is the one you'll predominantly see in online examples. Finally, to wrap up the topic of operators and variables, there's an important point to touch on. It's one of the additions made to the C# language over the years, and that is the use of implicitly declared local variables. Until now, we've declared variables by defining their data type, the variable's name, and, if we want, assigning a value. However, in C#, we also have the option to declare the variable type var, which is a special variable type that takes in the assigned type to determine the data type of your variable. So, for example, let's assign a value of 10 to an inferred variable here. If you look, C# doesn't flag any problem. However, if we hover over this var, we see that it indicates that the data type is int32, which is the same as the data type int. Therefore, we're inferring, or rather the compiler is inferring, that you're using an integer data type. If we add a 0 after the 10 and hover over var, we can see that the data type is now double. If we add an f, we see the data type is single. If we add an m, we see the data type is decimal. This means we're inferring the data type of the variable based on what we have here. This only works if you're assigning something. For example, it can be a string too. We see it detects that it's a string. However, if you just have this without the assignment, you'll see this will flag an issue. It tells us that it can't infer the data type because it needs to be initialized. So, this could be a time saver for C# programmers. There are people who like to use this form that we have here. There are people who, due to their company standards and other reasons, have to use a specific data type. But without a doubt, this is something we should be aware of if we come across code on GitHub or any other platform.